Hi, and welcome to HashiConf Global. My name is Blake Covarrubias. I'm a senior product manager on the Consul team, and today I'm here to speak to you about a new feature in Consul Enterprise version 1.11, administrative partitions. So first, let's look at a brief agenda for the presentation. First, we're going to take a look at common Consul deployment models. Next, I'm going to review common challenges that enterprises experience when deploying Consul in multi-tenant environments and discuss how Consul 1.11 helps address these challenges with administrative partitions. I'll then run through a quick demo of admin partitions in the alpha release of Consul 1.11. And finally, we'll take a look at upcoming enhancements for the feature as Consul 1.11 nears general availability. Let's take a look at a couple of common deployment models for Consul. A basic deployment of Consul consists of a set of Consul servers deployed within a single region, otherwise known as a data center. Consul clients can either be deployed on the same IP network as the servers or across different IP networks connected through VPC peering. Multi-network deployments are common in organizations that provide Consul as a service to multiple application teams or to different business units. Consul can also be deployed in a federated multi-region configuration. In this scenario, it's not possible to deploy Consul clients and servers in a single IP network due to latency issues across cloud regions or connections from the cloud to on-premise environments. So instead, each region is deployed as a separate Consul data center. Data centers are then connected or federated to one another over a wide area network, such as the internet. When using service mesh, application traffic traverses data centers using mesh gateways. Also, certain resources such as ACL policies, namespaces, and service mesh configuration are global to all data centers in the federation. This means that it's not possible to have policies or namespaces which are scoped to a single data center. Next, let's take a look at how organizations often deploy Consul in multi-tenant environments and challenges they can experience with some of these deployment models. One model is that an organization may operate a shared Consul cluster with common policies defined for users of the system. In this scenario, each team would be mapped into their own Consul namespace, and then operators might delegate a subset of administrative control to namespace level admins. Within each namespace, service and certain service mesh configuration are unique. However, as I mentioned earlier, there are other resources which are globally shared across all users of the cluster. Now, if this isn't sufficient and more autonomy is needed, organizations can give individual teams their own Consul cluster. But these deployments would essentially operate as islands with no service connectivity between the data centers. While this model provides the best separation between teams and offers more flexibility with regard to configuration, it also increases operational overhead. So let's look at why this is the case. First, each Consul data center requires its own set of Consul servers. This means additional infrastructure that must be installed, managed, monitored, and upgraded. And often, teams within enterprises are not looking to manage additional infrastructure. In fact, many are looking to adopt managed services, and deploying a self-managed Consul cluster goes against this trend. Also, without any coordination between teams, it's possible for different teams to deploy applications on overlapping IP space, and this could present challenges when applications need to communicate across those team boundaries. So far, I've focused on what it takes to support multi-tenancy deployments within Consul. Now, let's take a look at how organizations are separating applications in orchestration environments like Kubernetes. According to the CNCF survey from 2019 and 2020, namespaces are increasingly used within organizations to separate applications between teams, followed by provisioning applications into separate clusters. Now, similar to Consul, certain Kubernetes resources are not namespaced, and they're shared amongst all users of the cluster. Separate clusters can help solve for that if different configurations are needed, but again, at the cost of increased operational overhead. If we look at the CNCF survey data over the past 4 years, the number of Kubernetes clusters organizations are using in production has steadily increased, with 2 to 5 being the most common. Now, I've talked about some of the deployment models for Consul and Kubernetes to support multi-tenant environments. In large organizations where tenants are relatively autonomous and applications have different configuration needs, organizations may find that they need to operate multiple Consul and Kubernetes clusters to satisfy the needs of the business. However, again, this comes at a cost of increased operational overhead required to maintain the additional infrastructure. So now let's look at how Consul helps address these challenges. In Consul Enterprise version 1.11, we're introducing enhanced multi-tenancy controls with admin partitions. Admin partitions provide a more robust isolation layer than namespaces. Partitions allow operators to host multiple tenants on a single set of Consul servers and allow tenants to have complete control over their environment while eliminating the requirement for tenants to manage their own Consul infrastructure. Consul service mesh and non-service mesh configuration can be configured on a per-tenant basis. Admin partitions also support the ability to connect applications across partitions even when those applications reside on overlapping IP space. Let's take a more detailed look at a Consul deployment topology using admin partitions. So in this topology, the Consul control plane is a central cluster which is managed by a platform or infrastructure team. The partitions represent autonomous business units or teams within the organization. Each partition runs a set of Consul clients which connect back to the servers over a network segment. Partition administrators have full control over the resources scoped to their partition and their service mesh. And lastly, by default, configuration and resources within a partition are not visible to other tenants of the system, effectively providing isolation between tenants. Now let's dive into a demo of this new functionality. So for this demo environment, I have 3 Kubernetes clusters deployed into GKE. One of them will host the Consul servers, and the other ones will run Consul clients, which are deployed into different partitions. Let's take a look at the Helm chart configuration for the server cluster. We can see standard Helm chart configuration. This config is deployed with Consul 1.11. And you'll notice 2 new parameters here, admin partitions, and I've set that enabled to true, which enables it on the servers. I've also configured the servers to expose their gossip and RPC ports across the network to the other clusters within the VPC so that the tenant clusters can connect into this control plane. If we now look over at the configuration for the tenant cluster, we'll see a similar configuration. This time there's a new name field in the Helm config where I'm specifying the name of the partition in which these clients will join, in this case, tenant 1. If we scroll down to the server section, this cluster is configured to join external servers which are running in that central control plane. And the configuration for the cluster for tenant 2 is very similar. So now I'm going to jump over to the Consul UI. And you'll notice on the left-hand side that I have this new menu for admin partitions. If I click into that, I see the partitions for tenant 1 and tenant 2. So if we click into nodes in the shared cluster environment, we see the Consul server. And then if we go over to the tenant 1 partition, we just see the Consul client for that environment, and tenant 2, the same, a Consul client into that scope to that partition. If we take a look at services, at the moment, there are no services deployed in any of these environments. So let's go over to the command line and take a look at what we see there. So I have 3 terminals, one for each of the tenant environments. If we look at the current kubectl context, we're currently configured to access the shared cluster. And similarly, if I look at the Consul partition environment variable, we'll see there's no partition set because we're currently accessing the main partition in the main cluster. If I run Consul catalog services, we'll only see the default Consul service. And if I run kubectl get pods, we'll only see the server components deployed into this environment on that shared cluster. Now, if I tab over to one of the tenant environments, tenant 1, and I'm going to go ahead and change my context into tenant 1. And now I'm going to deploy some applications into this environment. You can see that application being deployed. I'm going to go ahead and run kubectl git pods and monitor that deployment. And we see those pods are initializing and now they're running. So I'm going to go ahead and Control-C out of that and look at the services that are deployed. Now this is a multi-tier application, but what I'm really interested in here is this front-end service. So I'm going to do kubectl port forward and expose that front-end service locally on port 8080. And then I'll copy the URL here and we'll log into that service. So now we see we have this demo application running. This is an application where you can purchase HashiCorp themed lattes. And so because it's a console demo, I want to purchase a cappuccino. But great, application's working. Let's go back over to console. And if we look at the services for tenant 1, we now see those services are deployed within that environment. But if we tab over to tenant 2, those services are not showing in the service catalog, nor are they showing in the shared cluster either. So they're just scoped to that partition which they were deployed. So we're going to go over to the command line and take a look at the same there. If we run console catalog services, we'll see those services that we saw registered into the service catalog. But then if we go over to the other tenant cluster and also run console catalog services, no services are available. Same thing we saw in the UI. So now I'm going to go to tenant 2 and deploy some services in that environment. So I'll switch my context to tenant 2 and now run a script to deploy those applications. This time, the services in this partition are being deployed in a Kubernetes namespace, which will then be mirrored into console. So we see the application is now deployed and it is, again, specifically within its own namespace named pod info. So I'm going to go ahead and run kubectl port forward to expose that locally. And if I refresh my page in the browser, now I have access to this other demo application. We can see that it's alive and it's working. If we go back over to the console UI and hit the drop down for tenant 2, look at now this pod info namespace has been synced to console and we can see this service present in the service catalog. The service is not in the default namespace, nor is it present in the service catalog for the other tenant. And if I run a console namespace list, again, we'll see that synchronized namespace in the tenant 2 environment. But if I switch over to tenant 1, the namespace does not exist in that tenant 1 partition. That concludes the demo of the new admin partitions feature in Consul Enterprise version 1.11. Consul 1.11 is currently available as an alpha release. Upcoming beta releases will add support for cross-partition communication using partition scoped gateways and the ability to selectively make services available to other partitions in the cluster. Consul 1.11 will be generally available later this year. Thank you for joining this session. If you have any questions, feel free to connect with me on Twitter or LinkedIn. Otherwise, enjoy the rest of your time at HashiConf.